I've been working on a factory automation game for the last few weeks, and this is a devlog to show what I've done so far. I've made a bunch of different tutorials on this channel. A platformer, a shooting game, a top-down dungeon crawler, and a lot more. But recently I've wanted to take a break from making tutorials and work on developing my own game. I really enjoy playing automation games, and would love to be able to make my own one. But these kinds of games can be very complex and far too big for me to take on. So for my project, I defined a small list of the main features that I want to have. I want to have resources on the map that I can extract. I want to be able to then process and combine these into other materials. And lastly, I will move everything around with conveyor belts. I hadn't fleshed the idea out too much, but the conveyor belts were going to be fundamental, so I started with that. My game would be top-down and grid-based, so it made sense to use a tile map. I drew a simple looking conveyor belt and made an animated tile set from it, which I can then place on the grid. I couldn't really test this without having something to move though. So I made a piece of ore that I placed in the game and was able to move it around with a conveyor belt. This seemed to work at first, but the problem was that it moved the item to the edge of the conveyor, and that's where it always stayed, so it ended up just riding around on the edges of each belt rather than in the middle. To get around this issue, I made the items snap to the center of the conveyor belt. The snapping looks a little odd, but for now I had a bigger issue to figure out. The items aren't aware of each other, so when I have multiple items in the game, they stack on top of each other. I needed to figure out how to get these items to interact with one another. I gave each conveyor belt an inventory, so that I could track which belt had ore on it at any time. Each of these belts would then look at the belt in front of them and see if that belt had an empty inventory. If it did, then the ore would be passed onto that belt, and this would repeat until the ore has moved to the end of the full line and there are no empty inventories left. And this is the result. The items move around as long as there is a space for them to move to. With the conveyors working a little better, I added camera panning and zooming so that I can move around the map easier. I also added an extra layer to my tile map where I can show the selected conveyor type so that you can see which belt you're placing down. This made it easier to replace an existing belt with one going in a different direction. And all the while I was fixing little bugs and adding more rules to the movement of items. For example, to prevent an item moving onto a belt that is facing in the opposite direction. The next big improvement was to be able to draw the belts using the mouse. I went for a similar approach to shapes.io, where the belts are placed in the direction of mouse movement with 90-degree turns added automatically. This wasn't too difficult to implement when the mouse moved one tile over, but if I moved the mouse quickly over a few tiles, the game wasn't able to fill that gap with belts. What I did to solve this was to take the last mouse position and the new mouse position. Then I used the A* pathfinding algorithm to figure out the path between these 2 points. I then used that path to place multiple belts. This worked even better than I expected, allowing me to quickly draw different paths for my belts. I didn't like the look of the perpendicular belts, so I drew up a 90-degree belt and added it as a second tile into my tile set. Working out how to place these 90-degree tiles automatically though was much more difficult. This was partly because the code for placing the belts was starting to get more complicated, and adding features risked breaking what was there before. I realized I would need to define some rules for how the 90-degree belts would work. If there is already a belt behind the new belt and it is pointing in the same direction, then the new belt must be a straight belt. If there isn't a belt behind it, but there is a belt to the side, then the new belt will be at 90 degrees. If there is a belt on either side though, then it's going to be a straight belt. And lastly, if there is a belt behind and to the side, then the one behind takes priority and it remains a straight belt. With these rules, it was easier to implement the logic. I then created a helper function that worked out the different transforms that would need to be applied based on the input and output directions of the belt. Now I can place belts easily. The path is automatically worked out with the pathfinding algorithm, which then determines the orientation of each belt. The 90-degree belts use the same logic for handling items as the straight belts do, so I didn't have to make any changes there. The items follow the path automatically and turn whenever they hit a 90-degree belt. Now that the belts were working, I wanted to improve these ugly looking images. I haven't made my own sprites before, and typically I rely on the open source sprite packs on itch.io. But for this game, I wanted to try creating something myself. So I got a sprite, watched a bunch of tutorials, and drew up my own animated sprite sheet. Getting the belt animations to line up took a lot of time, but eventually I got it figured out, and I'm quite happy with the end result. I also drew a little crate image using another tutorial, so now I have these crates being moved around on the conveyor belt system. This might not look like a lot of progress, but getting the belt system working should allow me to add more components easier. But that's for the next devlog. Let me know what you guys think of this project so far, and I'll see you in the next video.